Hi, this is Mr. Max. So I am doing today two questions from last year 2020, the high level question paper. The questions are question 13 and 14 respectively, and these questions are dealing strictly with trigonometry, and so I decided to take them together. Okay, so question 13 said a curve has an equation of y equals to minus 2 sin 3x plus 4. So you should realize that if you were to draw this curve, then this is actually going to be not a normal sine curve, which you know, and I hope that you should know how to draw the normal sine curve. The normal sine curve obviously starts from there. So this one here would be a reflection on the x-axis. So for example, the reflection of this one here will be something like that. So this particular curve, because of this minus 2 here, takes that particular form. Anyway, the question doesn't really ask us to draw any curve. I just thought that it's necessary or it's important that one also have to look at that. So the amplitude of the curve, so briefly, we're looking at that value there, but we have to look at the positive value because amplitude is that distance and it can't be negative. So that should be always a positive value. So in this particular case, the amplitude will be 2. Then the period of the curve, how many of those pictures will you have, and the period of a sine curve repeats itself after every 360 degrees or 2 pi radians. So you have got a value here in front, which is normally the value of b, and that affects the period. So since the sine curve and the cosine curve for that matter repeats itself after every 360 degrees, you're going to divide it by that particular value. Or if you want to use radians, you say 2 pi radians divided by 3. So the two answers could be 2 pi over 3 or 120 degrees. Any one of them will do. Right, then you are supposed to describe the transformation that maps the curve y equals to minus 2 sin 3x plus 4 onto the curve of y equals to minus 2 sin 3x. You should see that this is very easy. So if you look at the curve that I brought here, the green one represents this one here, and the one under obviously represents a downward movement. So you can see that it must be a translation, and we describe that translation as a vector. So wherever that one was, you will realize that it moved 4 places to where it get to this one. So it is a translation, and you describe it by that vector. You can pick any point 6 here and see where this point is now. So even 4 here where it cuts the y-axis, and you can see that with plus 4, and now you go down 4 places and it cuts it now at 0 because there is nothing here, it's just 3x. Here you're supposed to prove the identity, so I'm going to start first with the left-hand side. So I'm going to reduce the left-hand side. Remember, these are not equations. You're not doing things like the normal way of solving equations by cross-multiplying, taking squares on both sides. This is not what this is. You have to prove the identity. So I first do the left-hand side, and we'll write it as one term. And once we do that, it all becomes this particular value here, right? You will realize that the sine square x will cancel, but this here, the 1 minus sine square x, comes from here, which is the difference of 2 square if you multiply these two brackets out. Something else also, when you're dealing with the Pythagorean square identity of sin square x plus cos square x is equal to 1, if you make cos square x the subject of the formula, it takes this particular value here, so it can be replaced then by cos square x, and on top that simplifies to 2 sin x. So I'm going to leave the left side like that, and let me focus on the right hand side. So you have got 2 10x and sec x, so you have to change 10x in terms of sine over cos, and this is 1 over cos as an inverse. So that's what I did there. So simply multiply numerator of numerator and denominator of denominator. So you see that I have arrived exactly at the same place where I arrived on the left hand side. So therefore I have proven the identity. You have got an equation here. You're supposed to solve the equation for that particular period. So you need to make sure one or two things. Your calculator is in radian mode because the angles must be given in radian mode, because the interval here is minus pi radians up to pi radians. So it's like minus 180 degrees up to positive 180 degrees. So you're going to have some negative answers or negative angles as well. Right, then also you're going to change this sec into cos, but then you can let this whole 2x be replaced by some number. So since I know that sec of k is equal to 5 over 1, the inverse of sec is cos, so then I'm going to just take the inverse of the number there, which is 1 over 5. So when I'm here, I'm now going to look at two possibilities. When I deal with positive angles, it's from 0 to pi radians, and in that particular instance, we know that it's going to be an anti-clockwise direction. So our solution is going to lie for this particular domain. They are looking for values from minus to positive. So I'm going to look at the positive one. So theta will be one of my solutions, and the other solution will be 2 pi minus theta. For negative angles, that is now from negative pi up to 0, it's going to be in the same quadrants. That is why you obviously will have the same angle with just a positive and negative in front of them, because whatever your theta will be here you're going clockwise, it's going to be negative. Whatever this answer is going to be here, we're also going to consider that answer there, but then it's going to be negative. And I hope that you know the arrangement of the cast diagram once you're dealing with negative angles. So let us calculate that key angle there. Make sure, again, as I said, your calculator is in radian mode. And once you do that, you should get a cute basic angle, all right, of 1.3694384 radians. So that is one of our solutions. But now I have decided to replace the 2x with a k, so I'm going to bring it back. So in the first quadrant, 2x equals to that. I then divide throughout by 2 in order to get my first solution. Now when I go to the fourth quadrant, I have to take 2 pi minus 1.3693884, and then I'm going to isolate the x. First I get that value, divide by 2, I get 2.46. So these are already two solutions, but for the positive angles. But for the negative angles, it will exactly be the same, just with minuses in front. But I have done it here, and I hope that you realize I put the minus outside the bracket. So in the first quadrant, I have it as that. Or in the fourth quadrant here, it's going to be 2x equals to minus 1.369438. Then you divide that throughout by 2. And then in the first quadrant, I'm going to have in brackets, I have the same stuff like I have with the other ones here, but now I have a negative in front because I'm looking for negative angles, right? So in the particular case, you realize that you have exactly the same answers, just with different signs. So one answer will be positive 0.684, for example, the other one will be negative, and the other one will be positive 2.46, and the other one will be negative. So here we have got another equation that you are supposed to solve. So the domain is restricted only from 180 to 360. So we have got some sec square x, so we have to borrow something from our identities. So if I look at the first basic identity that everybody should know by now, that is sin square x plus cos square x is equal to 1. And if I go ahead and I divide throughout by sin square x, and then I'm going to end up with 1 plus 10 square x equals to sec square x, where this is 1 over sin square x. So the reason why I wanted this sec square x is because I want to replace that with 1 plus 10 square x everywhere where I have sec square x. So in a nutshell, that's what it's going to give me. And I'm going to distribute that 2 over, and I'm going to simplify that a little bit. So I see that this is some quadratic equation. So I'm going to say let 10x equals to k, so that it's a bit easier for me to deal with that quadratic equation. But remember, once I get to my final answers, I'm not going to solve for k, but rather I'm going to solve for 10x. Right, so it gives rise that my two solutions will be k is equal to 1 upon 2, or k is equal to negative a half, or negative 2 rather. So 10x equals to 1 over 2, or 10x equals to negative 2. Right, so while domain is restricted, we know that the tangent is positive in the second quadrant, and it's negative going to be in the fourth quadrant. So when I have the positive ratio here, I'm going to use that, and the negative, I'm going to use that quadrant. So if I look at my acute basic angle, so first I'm going to take a half. So I get 26.6. It's an acute basic angle, but it's not our solution. So our solution here is going to be, for example, 180 plus that angle. So that gives me 206.6 degrees, which is surely within our range if you look within our domain between 180 to 360, so that is an acceptable answer. When I take this reference angle here, or the acute basic angle, I'm not going to use the minus there. That minus indicates to me in what quadrant is cosine or tangent negative. I know that for this given domain from 180 to 360, that the tangent will be negative in the fourth quadrant. So I'm going to enter there a positive value so I can get the acute basic angle of 63.4, and I'm going to take away 63.4 in order for me to get that particular angle. So the two solutions here is going to be 206.6 as well as 296.6 degrees. Well, stand by for the other questions on the very same question paper.